Good afternoon, everyone, and thank you for joining us. This is Sarah Davison with Viavi Solutions Marketing. I want to thank you all for joining our call today on the indoor signal coverage mapping with the Neon Signal Mapper application. I have just a few housekeeping notes to share with you. This webinar is being recorded and will be available for you in approximately 24 to 48 hours, and an email to all attendees with a link with the recorded version will be sent out. All lines are on mute, but we are monitoring the chat and will answer questions at the end of the webinar, or we will reach out to you individually to ensure you get the answers you seek. And now I'd like to turn it over to our speaker today, Bill Nichols.
Thank you, Sarah. Good afternoon, ladies and gentlemen. Today we're going to talk about the indoor signal mapping using the Viavi 8800SX or 3550 radio test sets, along with the Neon Signal Mapper from TRX Systems. I am Bill Nichols, Field Application Engineer out of Wichita, Kansas. Also joining us today is Mike Portna and Dave Hansen, both Field Application Engineers, also out of Wichita. They're here to answer your questions as we go through the details of the indoor signal mapping. TRX Systems, located in Greenville, Maryland, got its start in public safety marketing. In the public safety market, responding to the requirements to safeguard public safety personnel when operating indoors where GPS does not work. Working with public safety to solve these extremely important and challenging problems has enabled TRX Systems to develop solutions based upon patented technology that seamlessly locate personnel anywhere GPS does not work. Just a little bit about the picture here. We have our 8800 SX on the left, and we're showing a Android device just to the right of it. Behind that, we have our PC, and just to the right of that, we have the 3550R. And below the 3550, we have our access point and our signal tracker. The Neon signal mapping for the 3550R and 8800SX uses the following components for the tracking. So we have the tracking unit, and that's the black device that you see below the PC there. That's what you wear on your belt. Have the TP-Link, that's the wireless router access point. That's an example of one down below the 3550 in front. You'll see another type here in a couple of slides. And then we also have the Neon Signal Mapper application, which resides on your Android. And then the Neon Command application, which resides on your computer. And you'll see with these four devices that we're going to be able to quickly do a full mapping of building and just, you know, in less than an hour, really. I actually did the whole mapping for this building you're going to see in about 15 minutes, and then the walkthrough took about 15 or 20 minutes. So you can do this very quickly. So what are the benefits of indoor signal mapping? Today we've got many DAS or distributed antenna systems being installed. Indoor signal mapping can help with verification of coverage. In the old days, you basically would go to a particular point on a floor called a waypoint, stop and make a measurement with a spectrum analyzer, looking at the power level at the location, and maybe have a radio to do a subjective audio quality measurement. This type of mapping took quite a while, and then when you were finished, you had to produce the results generally using an Excel spreadsheet. Processing this information took quite a bit of time. You're going to see today that you can quickly set up the map, quickly configure the maps, add floor plans to the building, and then do a walkthrough, all in a very short period of time. The other driving forces behind indoor signal mapping today are fire codes. The fire codes today in the US require coverage in new buildings, and if you're working under the international fire code, that's new buildings and existing buildings. And here are some cut and paste that you can see here from the code. And down towards the bottom there where I've highlighted in yellow, it says a minimum signal strength of -95 dBm. So that's what that's our target point for our neon signal mapping, and we'll get to that here in a little bit. So if you're doing international fire code, that's going to be in existing buildings also, and if it's US fire code, at least at this point, your existing buildings are grandfathered in. Okay, so some of the benefits to the indoor signal mapping, it integrates the Neon capability to automatically collect geo-reference test data with the 3550 or 8800 SX, and it saves valuable time and money. By automatically calculating the indoor location and correlating with the radio signal data, it limits the need for manual check-ins. By removing data recording errors caused by incorrect location estimates in complex buildings through automatic indoor path determination, this is all built into the Neon signal tracker. It also provides continuous logging of data with a high density of data points, including within typically difficult to map locations such as stairwells, elevators, and tunnels. It also supports rapid analysis and signal coverage with 3D visualizations and easy export of the timestamp data. And here's an example of the grid of the building that I did the signal mapping this week. And you can see on the map that it's pretty easy to see how many grids are in here. The grids can be automatically set in the Neon command, or you can set the grid size yourself. These grids are about 80 by 80. This building is approximately 280,000 square feet on the floor here, and it took about 16 to 20 minutes to do this walkthrough. The device that you see here is the Neon signal tracker. This is worn on your belt. You want to point it perfectly forward so that to get the best results, so it doesn't keep trying to get you going sideways. You get that straight forward, and you can get a real straight line on your points as you do the walkthrough. This device supports collection of processing of sensor data to deliver that 3D indoor location. Neon tracking unit includes the temperature compensated triaxial gyroscope. That's your X, Y, and Z axis so that you know which way you're going. It has a triaxial accelerometer to count your steps. Has a magnetic sensor so that it knows where the magnetic north is. And then also the barometric pressure sensor so that it knows whether you're on the ground floor, the basement, or the 10th floor. And this is the TP wireless router here. Basically, you're going to connect this through the Ethernet into your 3550 or 8800, and then it's got a USB connection that we use to power the device. So you just connect that USB port right into the 8800 or the 3550, and it'll power that device. Just said that, get that bullet point out of the way. So it does connect directly to the 3550 or the 8800. The Neon Command application runs on the Windows computer. This allows you to create your building before you do your mapping. We're going to actually run through this process to show you how easy it is to set up. And then once you've walked the building, you can upload to the cloud, or you can save it locally on the Android and then port it over to your PC. So this is just a before and after. So you're going to see this here in just a moment or two. setting up the map, and then this is just an example of the end results here. This is on the both on the Neon command, which resides on your PC. Okay, so this is, we're going to kind of go through the process here real quick. It took, in real time, it probably took me about 15 minutes to do this. So it really doesn't take very much time at all. They have some really nice tools in here to expedite the process here. So to get started, the only thing you have to do is go up to the search icon and either type your address in, or you have an address that you've already worked with and you want to maybe do another map of it. You can go down and select it from the list. Now, once it's located your building, you're going to see it on your PC, and then you'll want to use your mouse. You can use your thumb wheel to kind of zoom in and out, and then you can also use the left click to grab it and move it around the screen so you can kind of center it up. And once you've got it centered on the screen where you like it, you'll hit the file icon up at the top, or the drop down, and you'll select create building. And what that gives you the ability to do is draw an outline on your building. So you just start at a single point and you just walk around the building with your mouse and just make an outline of that building. Then once you've done that, once you've made the outline, then it's going to pop up a window and it's going to give you the ability to name that building. And that's where you can start to add your floors. In this example, because I wanted to show you how to do this, how this is done in the Neon command, I'm actually going to add 4 floors above and 3 floors below so I can show you some of the features in here. Once you've done that, the only thing you have to do at that point is go over to your icons and select the floor plan to add the floor plan. And you'll locate that on your PC wherever it might be. And you know, they can be JPGs or PNGs or bitmaps. And you'll just open that up. And it will somewhat self-center on the building, but you can kind of see that I've got a little bit of work to do to get this, you know, lined up with my outline. And there's a real neat tool to do that too. With you can edit this with points. So you go over to your icon and you select edit floor plan with control points, and it'll pop this window up here. And basically you just set these pins. You have 5 locations at once, so you just set these pins at each location. So you just you know, go around and set, you know, 5 separate locations on the building as we move through here. And then once you've done that, and you press OK, then you're going to see that it's very close to that outline. Now, once you've done that, if you want to clean up a few things, you kind of notice here that some of my outside lines don't quite match up with my building. We got a little overhang over here, and so if you want to go in there and clean that up, basically you will select the vertices, edit layout with vertices, and you'll just go in here and just select these points and just move them around where you want them. And once you've done all that, then it's going to ask you, do you want that your outline for the rest of your floors? And in a cookie cutter situation like we have here, then that's fine. But it also has the ability in there, if you you know, have a building that has a greater area on your upper floors, you know, maybe some balconies, that sort of thing. You can add areas and subtract areas from your various floors. But in this particular application, like I said, we've got a nice, should say, cookie cutter type of a building here. Okay, so once you do that, then you're just going to go through the process again, depending on however many floors you've got. You'll just go through and add those points, and it'll size that map into the outline of the building. So it goes very quickly this way. Now, I'm getting to the last floor here. You don't have to use a white background if you don't want to, and you can also manipulate the colors in the grids or heat maps. You don't have to do grids either. You can do heat maps and various types of map representation. But on my last floor here, I decided to use a negative for that floor plan, and so I just again using the edit points to put that in the building. And after you've done that, you may want to add some, if you've got a tall building, you're going to have elevators, you're going to have stairwells. Like we said earlier, that's a difficult place to map. And so you can add stairwells, staircases, like I said, elevators, doorways, ramps. There's many things that you can put into the building. So you'll decide what you want to do and locate those elevators or stairwells, if you will. And then you can also, at that point when you're putting the elevators in, you'll tell it which floors you want those elevators to go to. In this example, I've got one elevator that's going from the first floor down into the basement levels, and I have another elevator that's going from the first floor up. Once you've done all that, you can go into three-dimensional mode here. Your legend on the right side will give you the ability to do that. And so initially it'll say 3D up here, and you'll tap on that up here in the upper right. It'll put it into a 3D look on the map. And then you can actually go through and check each floor to make sure that they're symmetrical, and that's the way that you want them to look. And you can also do a 360 with the icons up here at the top. And again, you'll push and pull with your mouse to keep things centered up. But they've made this a really easy tool to use. So we're looking around. It looks like we like the way our building looks. And once you do that, you can go back into 2 dimensions and then go ahead and save your map. Now, when it saves, if you are on the network and you want to do it this way, you'll hit save and it'll upload it to the cloud. And then you can just get on your Android on the Signal Mapper, and you can just download this map to your Neon Signal Mapper, so you can do your walkthrough. Now, if you're government folks, a lot of times you are not able to use the cloud. So you certainly can store this on an SD card. And then once you get that on the SD card, then you can just load it into your Android, and you can do it that way. And there's no files on the network at that point. Okay, we're going to talk a little bit about the Android device on here. So the Neon Signal Mapper application runs on the Android device, and you have to supply the tablet. The mapper is used to guide the user while collecting your signal data. So you'll see that floor plan the way that we've laid it out. You're going to actually see your location on that floor plan. You'll see the cursor walking through the building as you move through, and you'll see the updates continuously on the map, so that you'll know whether you have good coverage or bad coverage, and whether you need to recalibrate your walk, which is real easy to do. we'll see that. Actually, yeah, we'll see that here in just a second. We'll talk about that a little bit further. So this is basically your setup as you walk through. You'll have your 3550 connected to that TP link with the Ethernet. We're not showing the USB, but you do want to hook that USB up to power the TP link. And you'll be wearing the puck, if you will, on your belt. And then, of course, you'll be walking with your Android with the signal mapper on it as you walk through the building. We talked a little about those bullet points. The only thing that you have to do on your service monitor is go in and pull a receiver up and the digital DMOD tile, and then just decide whether are you doing P25 NXDN or DMR. Those are all options in the 3550 that you could use if you have those options. And then you want to select your antenna port. And the only other thing I did was open the receiver up and turn the preamp on. And that's really all there is to setting up the 3550. Once it's set up that way, the Neon signal tracker actually will query those meters and display that information in the result file. And as you walk through this, is kind of one of the points I started to make a little bit earlier. When you're walking through, you're actually going to be able to, you'll see yourself on the map, and you can, you know, these Androids are touchscreen, so you can zoom in as close as you want. I like to zoom in really close when I'm calibrating my walk. Basically, what it'll have you do is when you initially start out, you'll be at a particular point in the building, and you'll use this icon that you see right here, the little eyedropper icon, and once you hit that, you can locate your exact point on the map, and then you'll press it again, and then you'll walk 10 meters, 30 feet, and press it again. And if it likes the calibration, it'll say that you're ready to start your mapping. This will turn green down here. And once you hit the start button, you will see an indication that it is going into P25 mode or NXDN or DMR. And then you'll get an indication of the type of measurement that you're making, whether it's signal strength, signal quality, BER, mod fidelity. You'll see that information at the bottom. And of course, as you're walking through, then you'll see the path that you're walking, and then you'll also be able to see, you know, if you're doing grid mapping, it's going to be green or red, and if you decide you want to do a heat map, then you'll have varying degrees of color for that heat map. So it's very easy to calibrate and very easy to do the walkthrough. Again, this is a kind of a portion of the building here, but 280,000 square feet, and was able to walk that in about 15 minutes. Now, once you've done that, then you of course want to you're going to upload that to the cloud from your Neon Signal Mapper on your Android, or you can store it locally and use an SD card on your Android to remove that file so that you can put it in the Neon command, your PC that's using the Neon command. And once you do that, you'll either going to go to the cloud to open this. So you're going to hit open, and it's going to give you, I did this through the cloud, so this is kind of the way it's going to look here. It'll open up all the folders that you've got, in this case in the cloud, otherwise you'd load it off your PC. But this is the particular one I did. You open the folder and you'll find the file in there. And once you've clicked on that, then you'll get this legend on the left side over here. And I know that it's kind of a little fuzzy to see what the verbiage in here, but this is actually my map. And so the only thing you have to do at that point is decide, do you want the display showing you signal power, signal quality, BER, mod fidelity, and then once you've decided what you want to plot, then you'll there's a little check mark here by the DL, which means downlink. And then once you've done that, you'll just hit generate map down here at the bottom, and it will populate the map, your generated map from your neon signal tracker into the map that we see here, or the display that we see here. So that's what it looks like. So this was the particular walk that I did. Now, there's a lot of different things you can do once you get in here. There's actually a timeline on here, so you can move the timeline and you'll see your walkthrough, or you can go in reverse. You can also zoom in very close to take a closer look at things. And you can also, make some adjustments if, there's points in the path you want to straighten out so that you get a nice presentation for the customer. You can go in there and adjust some minimum adjustments to your path. So this is just kind of showing the walkthrough here. And then of course, I'm zoomed in pretty good. So any location where you're out of spec when you're doing the grid mapping, then those grids are going to turn red. Now, if you were doing a heat map, then you would just see a heat generated signal around the path that you're walking. But for fire code, this is what they want to see of these indications in the grid. And this is what a grid would look like. This particular one here is floor 1, and we're just showing signal power here. And remember, our fire code is neg 95, so we're a little bit out of spec over here, but out of spec is out of spec, so these grids will turn red. And in this indication here, like I said before, we've got 40 grids showing up on our screen, and I believe these are 80 by 80 squares. So that's what a signal map would look like. And then inside of here, you're in this particular one, like I said, you're looking at power, and then also it's telling you what grid numbers we have out here. And if a grid didn't get mapped, then there won't be any indication there, or it might be gray. I was on the catwalk on the 2nd floor here, and there was one grid that was gray. It wasn't good or bad or indifferent. It just there just wasn't enough information to color that grid. And this is what you're looking for is areas where you have bad coverage, and you might need to put a BDA in. And we're going to see that we can go into any of these balloons here, if you will, and we can see the actual measurements at that point. Here is a different map. This is a signal quality map. This is a combination of all the measurements, and it tells you what the signal quality is. And notice that in those 2 grids previously on the power that were in red, because we were below neg 95, we have a good signal quality here. So you're going to get a good audio from the radio at those points. And this is, I was referring to, this is I got up on the 2nd floor catwalk here, and we got 3 grids out of it, and there's that gray grid. It did give me a number, but they didn't get enough information to decide whether that was going to be actually a red or a green area. So that's just kind of a gray area. And if I needed to, I'd want to go up there and maybe track that. It actually was a little bit off to the side of the catwalk, so actually this would be down on the 1st floor. So I would disregard that number 12 grid. And here's another grid with mod fidelity, and we're going to explain what mod fidelity is here towards the end of our discussion here. But mod fidelity is the P25 standard for it is mod fidelity has to be less than 5%. Again, I'm going to explain what that is here in a little bit. But you can see that we had a really good modulation fidelity in all of our grids down here, and even in our 2 grids that we were below neg 95, we still had that is out of spec, but is still indicating that we had good audio quality. And then over here, our signal was, we're gonna zoom in on this area hand a little bit and see what actual signal levels we do have out here. And they were below neg 100 up in this area, so that we do see that our mod fidelity is definitely getting a lot higher out here. Now, here is the transmit BER. This is another one of our measurements that we make here. And 0 bit error, when you have a good signal strength and a good, good audio quality, those birds are that bit error is going to be 0. If the bit error starts to go up, then you know that your audio quality is probably going to be impaired. Once you get above 50 or 60, you're going to start getting dropouts. And if you see a bit error of 100%, then that is a point where there wouldn't be any audio at all. And you might get your mod fidelity, you may still be getting indications of mod fidelity and signal level, but if the BER is 100%, then there's no audio coming through. And we can see that the number of measurements it makes in a grid, we'll see this here in a second too. There's about 20 some measurements that it makes per grid. And it's showing us here that it was about 23, but you can see up here we're at 100. And I'm gonna talk a little bit about the difference between what the radio test set measurements are and what an actual radio is gonna sound like. And we're gonna talk about that here in just a few minutes. And we're back to signal power here. Now, you don't only get the grids. You can have all the data information too. So if you need to put your information into an IB wave report, or you just want the raw CVS data, see if I can pull that up so you can see it. Let's see. I was hoping I was going to be able to pop that down. There we go. So when you do an export, all those grids that you saw, I was hitting the export and going to grid report, and then telling it what grid, what type of grid I wanted, whether it was signal power, mod fidelity, or whatever. But you can also export those the CSV reports for Excel. That's all the raw data. And then you can also, it'll export as an IB Wave report. So if you're working with IB Wave, you can certainly incorporate these files into IB Wave. So this is kind of the, getting the bird's eye view. And of course we saw these grids, but now we're kind of getting a, bird's eye view of what's going on. So we definitely need to do something in this corner over here, and we need to get a BDA in these two red locations here, at least on this particular floor. Now, of course, you're going to have to do this on all the floors, but this is our example here is the first floor. Now, the other thing that you can do with these maps on these bubble points here is you can just click on any bubble point, and it's going to tell you what the particular measurement was at that location. And at this one that I picked here, actually you see the mouse there. It's on the red one, but it actually is. I clicked on the green one just to the left of that. So that's what we're seeing here. So it's telling us this is the downlink. Our signal power at that point's neg 90. Our mod fidelity is 2%, real good. Burr is 0. So the signal quality is 78%. So that's good. And it's also reporting what the NAC code is. If you're doing, mapping public safety, you're probably going to be doing a trunking system, and there's going to be a network access code associated with that control channel, and you'll be able to you'll see that in your measurement too, at least in the grid window here. Now here we're getting into our area where it looks like we're going to have to do some work. We're going to have to get a BDA in here to amplify that signal into that area. And on our information up here, we're reading about neg 118 right now. and their mod fidelity is 41%, and burr is 100%. So at this particular bubble right here, I would have an audio cutout. Now, as I'm walking through here, that level's pretty low, but you would hear audio kind of coming and going at that point. And one of the things that I did when I got into this area, and as a matter of fact, I was right here, I wanted to see what it would sound like on a public safety radio. This is an example of a public safety signal. It's a P25 signal that I used. I was at 851.0625, and I was using one of our service monitors, our 3920, to transmit a speech pattern because I wanted to hear what that audio quality was. And so at this point, when my 3550 and my Neon signal tracker was telling me that my level was neg 118 and I had 100% burr, I opened that radio up, the radio receiver, and I was still getting good audio quality at that point. Now, I was also stationary, and as you move, that's going to make a difference, but I was getting good audio quality at that point. So I wanted to see what the difference was between what the receiver on the service monitor was telling me and what the actual radio that's going to be in that building during that emergency moment is going to be able to hear. And that public safety radio, I was able to walk to this location right here, and this is really only about 30 feet between these 2 points right here, until it was cutting out so bad that I could not understand the conversation at that point. So your radio test set, even those radio test sets, their receiver sensitivity is not like a public safety radio. It's not as good as a public safety radio. Your public safety radio is only going to be able to move, approximately 30 some feet further away from the source of the signal before it's going to cut out. So you do get a good indication of the audio quality using these service monitors. And like I said, if it's 100% bit error, that's going to be a cutout. Now, the thing that I did realize using the speech pattern is that when the burr is less than 100% and all of these readings, you are getting these readings, you're actually going to be able to hear the audio. So this can give you an indication of what that audio is going to sound like. And speaking of that, if you are required, because these fire codes, they're mandated by different municipalities and they have different things that they want you to test. And I've got some that they want that radio on your hip and they want to know what the radio sounds like. And we would call that a DAQ, or digital audio quality measurement. And in the Neon software, you have the ability to port that into the map also. So you can be at a particular location, and if you have the luxury of having the public safety radio and able to have an audio signal, which is going to be difficult unless you're working with dispatch and the fire department, and in a lot of cases that's difficult to do. You can make those digital audio quality measurements on those portable radios, and then you can go onto your map and pinpoint the area and put that at that waypoint, if you will, that digital audio quality measurement. So that is available in the Neon tracker. Now, a couple of things on, we wanted to talk just a little bit more about what mod fidelity is. Now, a lot of you guys that have been doing public safety know what this is, but some people may be new to this. So modulation fidelity is a measure of the jitter on the 4-level FSK, and I'm going to show you what that looks like here in a minute. And again, talking about these measurements, these 2 bubble points right here, I was at right here, neg 111.18 is what it was telling me at that particular bubble point. Mod fidelity was 23%, burr was 5%. The signal quality was 11%, but I would still be able to pick up the audio because like I said, I I could hear it at that point, even on another service monitor. Now you take one step, and now it's gone down to neg 116. I have a burr of 100%. That would count as a cutout on the audio. You would actually you would hear the audio cut out, and so you're going to get spotty. It's going to be spotty coverage, but we're well below our fire code here at neg 95. So we know that we've got some work we need to do in here. I just wanted to kind of clarify, or trying to correlate a little bit these numbers as opposed to what you might hear if it was an actual conversation going on. Now, this mod fidelity, just to give you just a little bit more information about this. In P25, it's called modulation fidelity, but if you're doing NXDN or MOTOTRBO, it's called FSK error. And there's the measurements, there's no difference in the measurements. They just use two different terms. The P25 is from the APCO standard, and NXDN is written off a European standard, the ETSI standard. But it is a measurement of the quality of the digitally transmitted signal, and the signal can have a phase jitter or instability causing reception issues, and that's what we're measuring here. It's RMS deviation error, if you want the real term for it. In P25, how this works, in P25 you have four signals. Basically, you've got the carrier shifting to these four signals. It's either plus or minus 0.6 kilohertz or plus or minus 1.8 K. And if you're in DMR and NXDN, these frequencies are different, but they're giving you the same information. It's a representation of a byte. One of 4 bytes, and the P25, NXDN, and DMR all use this 4-level FSK, if you will. And if you're on the 3550 or an 8800, you could actually see these the 4 signals displayed. So that's a little bit about that mod fidelity, what that term means. Now, just to wrap up here a little bit, our packages with our Neon tracker packages for our 3550 and our 8800, they are subscriptions, and you can either get a license for 1 year, 2 years, 3 years, 5 years. You can choose that at the time that you purchase the option for your 3550 or your 8800. And once you get that, then you have you basically will send you the files. You load it on your Android, load it onto your PC, and then you will be mapping in very short order. So I hope everybody has a little bit better understanding of the indoor signal mapping using the TRX Systems Neon Signal Tracker with the 3550 and the 8800. And if you, we're going to open the lineup here for our questions. I can't see any questions coming in. That's why Dave and Mike are here. They're going to be fielding those. And just this last slide here, if you have any questions, you can contact us here at rts.webinars@viavisolutions.com. And if you need any help with customer service on your 3550, 8800, or you have any questions, you can call the customer service line here at 800-835-2350. And in conclusion down here, I want to thank you for joining us, and please stay online after that presentation, and if you would, take a short 1-minute survey. Okay, I guess we'll go ahead and open the line up for questions at this point.
Okay, thanks, Bill. Sarah had a couple of poll questions she wanted to put up as well. I don't know if she's going to do that, I guess, after the Q&A, but oh, there they are. So while we're going through and answering some of the questions that have been submitted, please go ahead and answer the questions for the polls, and that's just kind of to help us understand more about your use or your needs for signal mapping and coverage mapping. So thank you for your time answering those. We did have a few questions submitted, and I know Mike and I have been going through them, and I know Mike's been answering quite a few of them. I'll go ahead and cover a few of those as well for everybody else. One of the questions that was asked was, Bill mentioned that the Signal Mapper, the application is written for Android devices, and that could be an Android phone or a tablet. Normally we'd use a tablet just because it's a little bit bigger, easier to see. But there was a question about whether it would work with iOS in the future. At this time, I don't know of any plans to add any Apple devices to, to support for Apple devices. That's something I'll have to check with the manufacturer of the software on. As Bill mentioned, this is a software package written by TRX, third party, and to work with our service monitors. So it's not something that we have direct control over. So I would have to check with them to verify that. But as of now, there are no plans to add Apple devices to it. So again, I'll check on that, Eric, and get back to you. At this time also, we do not have the ability to, the software does not have the ability to scan multiple frequencies. And that's something that again, is controlled by the software. So it's something I don't have control over, but it's something that we can always suggest, and perhaps in the future we could do that. But at this time, it's not a feature that is supported.
TRX has got a real great support department, and I was kind of thinking about that. We have the commands, to switch frequencies, so we may talk to them about that. And it's not something we can't do. It's just something that we just haven't asked them to do yet. I think that it's entirely possible to do in the future.
Right. Mike, feel free to jump in anytime too, if you have anything. Let's see here. Alex had asked about the measurement, I guess the measurements that we're capturing, and we're actually capturing many different measurements. And in fact, I think one of Bill's slides had a shot of the different things that you can select to have be part of the, I guess, what determines the signal quality. So things like the bit error rate or modulation fidelity, signal level, all of those can play a part in the measurement as you see fit. We do also work with all your P25 signal types, so C4, FM, LSM, P25 phase 2, all of those can be monitored. Let's see here, what else is in here? Jim asked about using the radio at the same time, and I know Bill talked about listening to the audio quality and doing a digital audio quality, not measurement, but what's the evaluation?
Yeah, digital audio quality. Mm-hmm.
Right. So when you're doing that sort of measurement, the DAC measurement, you're not actually transmitting from your radio, and so if you're you're monitoring a channel with the radio test set, and of course the Neon software is querying the radio test set for those measurements. Since the radio is not transmitting, it's not going to interfere with those measurements. Now, if you were transmitting on the same frequency, if you were carrying a radio with you and using it to communicate with somebody at the time, anytime you have the radio keyed up, if it is on that frequency, then yes, it certainly would have an effect. And so that's something that I guess you would need to keep in mind. But as far as doing a DAC measurement, that's not something that would that would impact our ability to monitor an off-the-air channel.
But you could use the radio for the DAC measurement if you have somebody on the system that either you're sending a tone, or you just have somebody keying up and talking to you, giving you a test 1, 2, 3. You can make those subjective measurements if you're carrying the radio.
Absolutely, absolutely. This is just as long as you're not keyed up, it'd be fine. Yep. Let's see here. Let's see. It looks like there are a couple of questions about the cost, and that's something that that the email address that Bill showed on that last slide. You can email that, and we can forward that to our sales team, and they can get a quote to you for that. You can also email us directly, and if you have questions about it, and we're happy to answer those as well. Let's see here. Just scrolling through the questions here to see what we haven't answered already. So there's a question here about for doing a DAS installation, to have their signals tracked, and I guess let's see here, application be used for signal strength measurements. Yeah, so in this situation, that would be the only difference really from our perspective, or from the Neon software's perspective, is that the signal wouldn't be coming from a tower over the hill. It would be coming from within the system itself, within that DAS itself. So as long as there's a source present, something transmitting on through that DAS, then we can measure the signal level. So whether that's a BDA, or whether you have a repeater in the building, whatever, as long as there's a some sort of source that is transmitting over that that DAS, we can measure that signal level and map it. So in that way, it's
weren't installed though yet, David. They just need an equivalent signal power at the same location where they would install the DAS, and then they could do the walk.
Right. Yeah. So this is actually, it's a good tool, for doing a before and after. You can walk through a building, a new building, and map the coverage prior to installation of a DAS, and then you can use that in addition to all of the predictive software. You can use that to confirm areas that need additional coverage or don't, and then you can go back through after that DAS is installed and verify that you do now have coverage in areas that you didn't before. So Michael, yes, the big advantage of the Neon Signal Mapper software is that all of this, the whole mapping part of that is automated. So where Bill mentioned at the beginning of the presentation, in the old days, you'd have to carry your laptop around with you, and you'd make a measurement, and you'd put into your spreadsheet a signal level at this waypoint, and then you get back to the office and you compile all that data and you dump it into another program, and it takes all of it and puts it onto this, into a map for you. The way that this product works, it does all that for you. So you walk through the building, once you've set up that map and loaded that onto the tablet, you walk through the building and the software takes care of all that for you. So it's constantly monitoring those signals, and it's going to automatically put that on the map for you. And then once it's there, the data is there, you can use that to generate your grid. You can use it to generate a heat map. And then, like Bill said, you can export that information as well. So it makes it a whole lot more streamlined, a lot less cumbersome to compile that information, because the software does it all for you. Okay. Well, I know we're getting close to the 1 o'clock mark, and so I think we'll go ahead and wrap up there. If there's any other questions, I guess we'll we'll get back to you. We'll follow up with you offline. But at this point, I think we're going to wrap up on our end. Thank you all for joining us, and hopefully you learned a little bit today, and contact us if you have any additional questions. Sarah, is there anything you'd like to say in closing?
No, that's it. Have a great afternoon.
Thank you, everybody.
Thanks a lot, everybody. Have a great day.